Inactive vaccines. What is inactive vaccines? There are several types of vaccines that can be used to fight diseases. Inactivated vaccines are composed of dead or inactivated virus and bacteria, and therefore different from live but attenuated vaccines. How are inactivated vaccines are made? To make an inactivated vaccine, the virus has to be grown in cultural media. This can be often the initial limiting step of vaccine production, as producers need to understand what conditions encourage viral growth. Inactivation of the virus is done with heat. Occasionally, inactivation is done with chemicals such as formalin. When the vaccine's under production is fractional, meaning it's protein or polysaccharide based, the vaccines undergoes further purification so that only the subunits of interest remain. Advantages of inactive vaccines. Inactivated vaccines can be provide high level of protection against disease of the dosing and booster regime is followed. Top up doses are needed, as will be discussed in more details later in this article. But if they are taken as advice, then the immunity offered by the inactivated vaccine is a very high standard. One of the risk of live attenuated vaccination is a possibility of reversion, and this is not the issue with the inactivated vaccine. Live vaccines contain living viruses and bacteria that have been treated in such a way that they are no longer virulent or threat to human health. One of the concern in their use, however, they may undergo changes in their genetic code that would lead to their return to dangerous wild from this disease. This is called a reversion, and because inactivated vaccines are dead, there is no risk to any change that would pose the threat to human health. Because dead pathogens do not actually attack the human body. Inactivated vaccines can be provided to people suffering from the immunity issues, as people are referred to as immunocompromised, which simply means to their ability to defend themselves against infection has been diminished. Examples of immunocompromised populations are people suffering from the HIV, a virus which can directly attacks the immune system, or cancer patients receiving chemo or radiotherapy, both of which damage the immune system and suppress it. These people are particularly vulnerable to pathogens, which is why even attenuated vaccines can pose risk. Disadvantages of inactive vaccines. While there are many advantages to their use, there are some distinct disadvantages to inactivated vaccines, which are important consideration when choosing which method of vaccination is the best suited to purpose. Some inactivated vaccines are less effective than their live counterparts, and while a live vaccine triggers an immune response so strong that usually a single dose is enough to immunize a person, inactivated vaccines need regular booster injection. This is not only inconvenient and sometimes unpleasant, where multiple injections are needed, but poses a real practical problems for travelers and the areas which the healthcare system is not established enough to conduct regular and routine vaccination for its resident population. One of these issues is inactivated vaccines that they don't effectively stimulate an element of the immune response called local or mucosal immunity. This is, however, stimulated by live vaccines. Mucosal immunity is an important front-line defense that deals with a lot of pathogens before they make their way into general circulation. A great example of key element of the mucosal immune response is an antibody called immunoglobulin, which found mucosal lining of the respiratory tract and prevents a lot of infection around the lungs and throat. Inactivated vaccines can sometimes be quite expensive because of the treatment process involved in inactive vaccine. This is obviously a major concern when it comes to large-scale immunization programs where millions of doses are needed. Example of inactive vaccines. Inactivated vaccines could include whole cell inactivated vaccine, example polio, hepatitis A, and rabies vaccine. Subunit vaccines, example influenza toxoids, example diphtheria and tetanus toxoid, and recombinant vaccine, example hepatitis B, human papillomavirus, and influenza. Thank you.